Hello everyone, welcome to another video. So we're still on how to set up a testing environment topic. We are also in the same project, ECU doors testing project. So in this video, we'll see how to prepare the project structure in your laptop testing before starting any activity of test. Okay. So the idea is to create a main folder called ECU doors config, which will contain all the files and configuration related to the test environment of our projects. And inside this folder, we organize the project into several subfolders, okay? In order to keep everything clear and structured. So first we have the DBC folder, which stores the CAN database describing the methods and the signals using in our CAN network. Next, we have the ECU simulation folder, where we implement the simulation of the ECU behavior. And we have the panels folder used to create the graphical interfaces to interact with system during testing. Okay. We have also the test files folder, which contains the couple test scripts or your automated test kits. Okay. And then we have another folder called test reports, which stores the generated test result and all the logs of your testing. Also, you can create the test unit build output, which contains the compiled output generated by the test framework generated by VTest Studio when you compile your test unit. Okay. We have finally the VTest project folder, which holds the test project configuration used to create and manage all the automated test keys. Okay. So this is how we will organize our folders for the ECU doors testing project. So this structured setup helps keep the testing project organized and makes it easier to maintain and scale. Okay, so it's very important to have a good organization of your folders. Can help us to progress. If we have some modifications or if we have something is not going correctly, we can localize it. Okay, so it's like you segment, you perform some segmentation of your global project. Okay, so this is the good way to start your activity. Okay, so once the folders are created, the next step, what is the next step? Let's see in the next slide. The next step is how to set up a vector testing environment. So we work always with the vector tools, GNU and VTest Studio. And then in this step, we will see the global plan. Okay, once you create your folders, you will put your global plan of your testing activity. Okay, so we have three main steps. We have the setup of GNU, testing with the GNU test feature set, and the last step is conclusion. Okay, so for the first, we have creating a CAN database. Okay, so this is the first step of the setup of GNU. So our network database is not required, but it's always helpful to have one. In most of test application, and network database will save a lot of time and effort in implementing the test cases. So if one is not available in your project, creating a database, it's a good first step. But in general, if you work in a real project without simulation, you have a real ECU that's, in a company, for example, the DPC, you can use it as an input, no need to create one. So you can get it from your control teams or from your supplier, and also you can get it from your customer. Okay, so it's something static and something used as an input in most of cases. Okay, but in our example project, we will see how to create it in the next video. Okay, we have also setting up Canoe. So the Canoe environment needs to be set up to that all the components can interact with each other, and the simulated ECUs and the remaining bus simulation must be created using couple in this level. Also, we have the system variables, which are used like a global variable. So in this project, we will use the system variables to control the engine and the console ECU simulation. Okay, from other components like the panel and test unit. So you can use the panel to control your engine and console ECU. So we will see in details in the next video, of course. So keep now just the title of each step. It's a global plan. Okay. We have user test plan. We talked about it. It's a graphical panel, can be created using panel designer in your Canoe tool. So it's recommended to create one. Okay. We have also verified the configuration. It's like debugging your Canoe configuration before starting your real validation or your testing. So you check your configuration if it's working correctly before starting the test. Okay, you check also the communication, the kind of communication, if it's working correctly or not. Okay, it's like kind of debugging. And then we have testing with Canoe test feature set. We have two kind of test setups. We have test unit and test modules. Okay, so the test unit is used for executing the test cases created using VTest Studio, and the test modules are used for executing all the test cases created in Canoe environments. Okay, so test modules execute the test case created in Canoe. Test unit for executing the test cases created in VTest Studio. Okay, so we have two types of test setup that we can find in our Canoe setup. We have testing in Canoe, so we will test the test case in Canoe. So Canoe has a built-in testing feature where test cases can be implemented in couple language. With couple, the test cases will be executed in the order in which they are written in the couple browser. Okay, so exactly are written in the main test control. So we have a main test, is a main program, like let's say main program, it's a main test, and you call all your test keys in this main test function. It's a global function. Okay, we will see in details, of course, in the next videos. So just keep in mind the global plan. Okay, and then we have a conclusion. But before the conclusion, we have another step in the testing with the Canoe test setup. So this step is testing with VTest Studio. So we can also perform some testing using VTest Studio, which provides a structured environment for for developing and managing automated tests. Okay, so and at the end we will do some conclusion. Yeah, some conclusion. Okay, so this is the three phases that you should follow. How to set up a vector testing environment. This is the global plan. Each phase contains some steps, 4 steps, 3 steps. Okay, so this is the global plan. So let's see what we have in the next slide. In the next slide, it will be dedicated to the setup plan. Okay, it will be about the first phase, the setup. Okay, the setup canon. So we need to create a CAN database is the first thing. So we will see how we can create a new file of database, how we can create a ECU nodes in our database, how we can create messages in our database, how we can create signals, CAN signals, how we can associate the database, and then we have setting up Canoe, which we will have some steps. Add node to the network, so you have your network and you map your node to the network. We can also create simulated doors ECU. How we can create system variables in Canoe, and also how we can add remaining bus simulation. Okay, the third step, user test panel. Okay, we see how we can create a new panel in Canoe. We'll see how we can add controls like some buttons, some test box, and then we have verify the configuration of 2 steps. We will see how we can check the CAN simulation. So the CAN we simulate the CAN bus and we see the exchange between our ECUs, it's working correctly or not. And we'll check the functionality. It's like some checks about the functioning of our communication. Okay, so this is what we have as steps to set up your kernel. Okay, we have 4 steps. Create database, setting up Canoe, use test panel, and verify the configuration. Okay. Thank you for watching. See you in the next video.